Hi there, my name is Dr. Marissa May. In this video, we're going to be exploring methods for addition. Now, that may seem like, oh, I know how to add, I don't need this. But what I'm going to do in this video is show you the different ways that students are taught addition. I'm going to move beyond just what we call the standard algorithm, which may be the method that you previously have learned. And I'm going to show you different ways that we teach students from early grades to a little bit higher grades to add with fluency. So let's take a look. First approach we're going to look at is the number line, where we use a model to show the addition. Let's take a look at the first problem. Nathan had a gummy rope that was 25 inches long, and Aaron had one that was 35 inches long. How long were the ropes altogether? Well, of course, we want to add these two together. And I want you to really try not to do the standard algorithm in your head, but instead look at the model and let's go from there. So if we're teaching a student who doesn't know the standard algorithm to use a number line to add, the first thing we would do is to tell them to mark the first number. So 25 is right here. Then we would tell them to jump 35. Now, of course, we don't want them to do 1, 2, 3. We want them to use a little bit of speed. So maybe you have them jump by fives. So that would be 5, 10, 15, 20, 25, 30, 35. And of course, where they land then is their answer. Remember, sometimes students won't know the standard algorithm, so they need a model to begin with first, and the number line definitely does that. Now, look at my second one, which is kind of where a lot of my students who are adults or maybe pre-service teachers get confused because they have to read the number line and they're used to doing the standard algorithm. So we're going to take a look. Let me minimize my video to make that a little bit where we can see the whole number line. There we go. That's better. So what we want to do now is to write the addition equation that this number line is showing. So you can see that it started at 49. And then how many did we jump? Well, this one actually jumped by one, so we got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So they added 14 to then land at 63. So you see how if the number line is drawn, you can actually read the problem from it. Now, let's take a look at a different model next. Another model that teachers use with students is the base 10 blocks. And these are blocks that students can actually touch and manipulate, which I love. And for some of our students, they need that. What we're going to be doing is to write the addition equation here that is displayed. So notice that the rods have 10 blocks in them. So this is 10, 10, 10, which would be 30. And then we have one block of 1, 2, 3, 4, 5. So this is actually 35. Okay. And then if you look at the bottom, you have 1, 2, 3, 4, 5. So you have 5 10 rods and you have 3. So that would give you 53. And then so you would add 35 plus 53, and you could see that we would get 8 10 rods and 8 unit cubes. Okay, so that's how you can use your 10 blocks to write the addition equation from it. And you can see how our students would also use these blocks to help group the 10 blocks together, right? And group the unit blocks together to write their addition problem. All right, my next method I want to share is the expanded form method. And friends, I have to be honest with you, this was a method I was not familiar with until one of my own children brought it home from school. And I was like, oh my goodness, I've never seen this. Show me. So I'm going to share with you in some of the same verbiage that my child used, how the thought process goes. We're going to start by the problem 35 plus 26, okay? And what we needed to do is to take the 26 and rewrite it as 20 plus 6. And when I ask my child, why did you do this? And they said, Mom, because it's easy to add 35 and 20 because the 20 has a 0 on the end. I was said, oh my goodness, you're right. So tell me more. So after we then broke down the 26 into 20 and 6, then we added the 35 and the 20. Because remember, that was the part my child said, oh, that's easier to add. And they were right. So then I said, okay, what do you do with the 55 plus 6 that you have left over? And they said, oh, this is easy. We split the 6 into 5 plus 1. And I said, why do you split the 6 into 5 plus 1? And they said, because adding 5 to 55 gets us to 60. Again, a number that ends in 0. So throughout the whole process, my child was looking to find easy addition that gets them to a number that ends in 0. Some of the elementary teachers that I've actually talked to, they said, we call this making 10. We want the child to continually look to find value, do these simple additions that get them to a number that ends in 0, and we call it making 10. I said, I'm all for it. So now if we finish this problem, 55 plus 5 gives me 60, and then super easy, 60 plus 1 is 61. Now you may say, wouldn't it just be easier to do the standard algorithm? And I would say yes, okay? But that's because I've learned the standard algorithm. What if I'm working with a student who hasn't learned that yet? Also, notice in this problem, there's no carrying to think about. There's no regrouping. The student never had to consider that. Okay. So for some of your students who may struggle with that carrying concept in the standard algorithm, this method bypasses that. They don't even have to think about it. So I think it's worth a look at it to see if that may be help a particular type of student. All right, so let's look at one more problem with this expanded form. And this time we're going to be working with a 3-digit problem because I think it's worth the effort to kind of talk through that. So let's look at adding 290 plus 540. And again, remember, we are looking to make 10, okay? In this case, 100. But we'll look at it too. The first thing I would do here is to take the 540 and split it into 10 plus 30. You may ask me, why would you do that, Dr. May? Because what am I trying to do with the 290? I'm trying to make 300, right? So when I have a 3-digit number, I'm trying to make hundreds. So I split the 540 into 10 plus 530, and now I'm going to add the 290 plus the 10 to give me 300. All right, so what would I do with the 530 next? I'm going to split it into 530 because 300 plus 500 is super easy to add. So I split the 530 into 500 plus 30. Then I do the 300 plus 500, which gives me 800. Now I can add the 30 to get 830. So when we're working with 2-digit numbers, we're looking to make 10. When we're dealing with 3-digit numbers, we're looking to make 100. Okay. And so you can split your other numbers accordingly so that you make that addition super simple for your students, for yourself. And again, this did not involve any carrying that would have happened in the standard algorithm. So I think it's a worthwhile approach for us to look at as a resource, as a tool for some of the students. All right, finally, we are on the standard algorithm. Now, I've referenced it several times in this video, but I just want to do a review. If you didn't know what I meant by the standard algorithm, that's where we stack the numbers and we add by place value. So we begin here with 1 plus 5 would give me 6, and 6 plus 2 would give me 8, and 3 plus 2 would give me 5. Super simple. And then I referenced earlier about carrying, so I thought I'd do an example of that. When we add the 8 and the 6 here in the ones column, we get 14. So I write the 4 and I carry the 1. Now in the tens column, we add 1 plus 2 gives me 3, plus 3 gives me 6, and 5 plus 1 also gives me 6 there. Again, this is a standard algorithm. If you are a little bit older, you've probably learned the standard algorithm at some point in your educational experience. I know I sure did. The other methods, however, are good methods, and I think they're worthwhile for some students. And so I mention them because I want you to be familiar with them so that you're not caught off guard when you see a student using them, or even better, you have a resource to help a student who may be struggling with the standard algorithm. I hope this helps you kind of increase those tools to help you reach students. Bye for now.